Okay, in this video we'll do an example of a separable differential equation. So find the general explicit solution to the differential equation dy dx equals y squared times cosine 3x. So what tells me that this is a separable differential equation is that I have a function of y being multiplied by a function of x equals dy dx. Whenever you have something like this, which is a function of y, say g of y, times a function of x, h of x, equals dy dx, this is going to be a separable differential equation. And the way we can solve this is we can get the y terms on one side and the x terms on the other. So since we have a dy here on top, we want the y terms on the left, and we want the dx terms on the right. And so we can divide by y squared and get 1 over y squared dy equals, and then we can multiply both sides by dx, cosine 3x dx, and integrate like this. Now when you look at this, it looks like it's not justified, but there is a formal justification of this method. Right? I mean, it's perfectly natural to wonder, okay, what does multiplying by dx on both sides, how does that even work? But it turns out that this does work, and that's hopefully something that you learn about when you learn about solving separable equations. How does this method work? But mathematically, it doesn't make any sense to multiply both sides by dx and then just put an integral sign. Okay, so the left-hand side is going to be the integral of 1 over y squared. Okay, let's make sure we review how to do that. So to integrate something like this, with respect to y, we can write this as the integral of y to the minus 2 dy. And when you integrate something, the variable raised to a power, you can just add 1 and then divide by what you get. And so the integral is going to be y to the negative 1 over negative 1 plus c. And you can check that the derivative of y to the negative 1 over negative 1 is y to the negative 2. And this is equal to negative 1 times y to the minus 1, which is negative 1 over y. So on the left, I have negative 1 over y. Well, I have plus c, but I have a plus c on the left and a plus c on the right, like a plus c2 on the right, and then if you subtract the constant, you're just going to get a constant on one side. So we can just put the arbitrary constant on the side with the x. Now to integrate cosine of 3x, you could do substitution, but when you have a constant, cosine of a constant times x, the antiderivative of cosine x is sine x, and you can do the thing where you take sine of 3x. Now sine of 3x is not correct because the derivative of sine of 3x is 3 cosine 3x because of the chain rule. But if you divide by a third, now when you take the derivative of this, it's going to be cosine 3x, because what's going to happen is the 3 from the 3x comes out, but it's going to cancel with the 1/3. So you get 1/3 sine 3x plus c. You may want to review the basic integration if you're having trouble with doing this integral. So now we want to solve for y, right? We're trying to solve for y here, and I see a negative sign, this negative sign here. Let's just get rid of that. We can multiply both sides by negative 1 and get 1 over y equals negative 1/3 sine 3x. Now it's going to be minus c. If you subtract an arbitrary constant, you just get an arbitrary constant left. So we can write this as plus, say, c1, just to indicate that it's not the same as the c before. And now what can we do to get y? We can take the reciprocal of both sides. Y equals 1 over negative 1/3 sine of 3x plus c1, but I'm just going to replace the c1 by c, okay, because because the symbol just stands for an arbitrary constant. Okay, and that's the answer. Okay, thanks for watching.